The renowned Chinese company EDI Robot has released another video showcasing the production process of their humanoid robots. Like all previous videos from the company, this new video has become a hit and literally went viral. As a reminder, at the EDI Robot's factories in the coastal city of Dalian, engineers are working on enhancing humanoid robots, focusing particularly on facial expressions and emotional reactions. As noted by EDI Robot CEO Li Boyang, androids represent the most complex direction in robotics. The process of manufacturing one such model takes between 2 to 4 weeks, and prices range from 1.5 to 2 million yuan, approximately $280,000. The workshop is scattered with silicone face masks, hands and feet, while humanoid torsos stand at various stages of assembly. Founded in 2013, EDI Robots positions itself as a high-tech enterprise specializing in the research, development, production, sales, and service of intelligent bionic humanoid robots, a recognizable brand in the industry. However, for now, the primary purpose of the humanoid models is to serve as live exhibits at the EDI Future Science and Technology Museum, located on the premises of the EDI Robots factory. At a meeting, Forschung Centrum Informatica in Karlsruhe, a unique robotic hand capable of performing delicate and precise manipulations with various objects, was presented for the first time. Research on the development of the manipulator with artificial tendons was conducted as part of the European project Dex Smart. Handling different items, such as a paper cup filled with juice, is easy for us, but poses a significant challenge for robots. Researchers have developed a mechanical hand that can easily perform these tasks and is equipped with more actuators than there are muscles in a human hand. Extremely durable polymer tendons enable the robotic hand to lift 5 kilograms objects at a speed of 30 millimeters per second using just one small electric motor and a 20 centimeters long tendon. Each finger of the robot, like a human finger, consists of 3 segments controlled by individual tendons. The new manipulator can effortlessly lift heavy objects, while simultaneously handling fragile items, such as a chicken egg, with care. Such machines can be used for collaborative work with humans, in surgery, and for performing complex repair tasks in hazardous environments. One of the key robots developed under this project features sophisticated sensory and motor systems, enabling it to handle intricate manipulation tasks that require human-like dexterity. This robot is designed to enhance the capabilities of service robots, making them more efficient and versatile in various applications by mimicking human arm and hand movements. By incorporating advanced technologies, such as 360-degree sonar detection and multi-axis arms, the Dex Smart project aims to push the boundaries of what service robots can achieve, particularly in environments that demand a high level of dexterous manipulation. Marco Tempest calls himself a cyber illusionist who works at the intersection of magic and technology. At a TED conference dedicated to robotics, Marco Tempest demonstrated the capabilities of the robot EDI. EDI, which stands for Electronic Deceptive Intelligence, is Tempest's latest techno-aid, a friendly Baxter robot who ponders the difference between artificial and human intelligence. Tempest says, "Mechanical robots of yore, the Victorians performing thinking machines, were mere illusions compared to today's intelligent robots. EDI, on the other hand, is very real, with a 360-degree sonar detection system and 2 7-axis arms." Tempest says, "We are intrigued by the possibility of creating a mechanical version of ourselves. The perfect robot would be indistinguishable from the human, and that scares us. Since we can't read the facial features of robots, for example, we can't anticipate their actions, but that goes both ways." EDI agrees, "Humans are unpredictable and irrational. I literally have no idea what you guys are going to do next time." The FZI Research Center for Information Technology's House of Living Labs developed HALI, an advanced service robot designed for various complex tasks. HALI stands 142 centimeters tall, with an adjustable shoulder height ranging from 96 to 124 centimeters, thanks to its active torso. The robot boasts 49 active degrees of freedom, enabling highly dexterous and precise movements. Equipped with a 360-degree sonar detection system, HALI can autonomously navigate and interact with its environment. Its cameras provide artificial vision for object recognition and interaction. HALI's bimanual manipulation capabilities allow it to bend and reach the floor, performing tasks that require delicate handling. Originally known for roles like a robotic bartender and pastry decorator, HALI is also capable of assisting with healthcare tasks and various service-oriented applications. The robot's development aims to achieve human-like dexterity and enhance human-robot interaction in everyday scenarios. The Japanese National Agriculture and Food Research Organization, in collaboration with Ritsumeikan University and auto parts manufacturer Denso Corp., has developed a prototype harvesting robot capable of picking fruits at the same speed as a human. The Japanese fruit tree industry is experiencing a decline in the number of workers and an aging workforce. To address this, a prototype automated fruit-picking robot was developed to harvest apples, Japanese pears, and Western pears from V-shaped trees. The prototype robot moves between trees using unmanned ground vehicles and picks fruits with its 2 robotic arms. The harvested fruits are collected into an automated fruit storage system. When the container of the automated fruit storage system is filled, it is replaced with an empty one while the robot continues harvesting. According to Naro, the prototype picks 1 fruit approximately every 11 seconds, which is about the same speed as a human. F&P Robotics AG developed Leo, a mobile service robot designed to assist healthcare professionals in various settings, including hospitals, nursing homes, and rehabilitation centers. Standing at approximately human height, Leo is equipped with autonomous navigation capabilities, a functional arm for grasping and transporting objects, and a 360-degree sonar detection system for environmental awareness and safety. Leo interacts with patients through voice and touch interfaces, providing companionship, encouraging activities, and assisting with routine tasks, such as delivering items. By performing these tasks, Leo helps reduce the workload of healthcare staff by up to 3 to 4 hours per day. Additionally, Leo enhances safety by patrolling facilities to detect unusual activities and potential hazards. Customizable to meet specific needs, Leo integrates seamlessly with various devices and systems, ultimately improving the quality of care by allowing healthcare professionals to focus more on patient care. Lauren V is a hexapod robot developed by the Fraunhofer Institute in Germany and is the 5th version in the Lauren series. It is designed to perform tasks in hard-to-reach and hazardous areas for humans, such as scientific research, rescue operations, and other scenarios requiring high mobility and stability. The robot is equipped with 6 legs, each with 6 degrees of freedom, allowing it to navigate effectively over complex and uneven surfaces. Lauren V is outfitted with various sensors, including cameras, laser scanners, and force sensors, enabling it to navigate its environment and perform precise manipulations. These sensors help Lauren V collect terrain data and detect objects or hazards, which is particularly crucial during rescue operations or research missions. Write in the comments what you liked most after watching this video. If you enjoyed the video, don't forget to subscribe to our channel and leave a like. See you next time.